Hello everybody, Mr. Taylor here again. Taking a look at 11.21. So again, we are working with equations with variables on both sides, but now we want to take a look at solving those equations that involves fractions. As we go on, or as you go on in your mathematical journey, you will find out the hard way, like I did, not being a mathematician, but more so on the business side, that fractions can be your friend, but they can also can cause you a lot of work. So you will learn to literally clear those fractions or turn those fractions into integers as often than not. Anyway, let's take a look at what our learning objective is for this particular lesson. Is students will solve equations with rational numbers, coefficients, and constants. And again, first of all, we're just going to simply look at fractions and not decimals in this first one. Key vocabulary again is rational numbers, a number that can be expressed as a ratio of two integers, or a decimal that terminates, which means it has a remainder of 0 when you divide, or a decimal that has a repeating pattern. You want to definitely keep that in mind as we work through. Well, the book says solving an equation that involves a fraction. In order for you to solve the equation with the variable on both sides that involve these fractions, you have to start by eliminating the fractions from the equation. You know, as long as you do everything to both sides of the equation, you're not going to change the value of that equation, and that's something that I don't be afraid of and just sort of understand as we work through. So let's take a look at the first problem that the book goes through for us. It says solve 7/10 n plus 3/2 is equal to 3/5 n plus 2. Well, back in your elementary part of your math, you learned something which is called finding a least common denominator. So that is the first concept you want to utilize here when you look at the denominators in these particular fractions. I see a denominator of 10. I see a denominator of 2. I see a denominator of 5. And then we can also look at that plus 2 and look at that as actually 2 over 1, and we see that a denominator of 1. So how do we go in and find the least common denominator, or the smallest number that each one of these 10, 2, 5, and 1 will divide into equally? Well, we can do so by a factoring tree, by doing starting with 10, since it's the first number that we see, and 10 times 1 will give us 10. Then we can move on to, let me put this down here for you. So we could say 10, or should we say 1 and 10, and then we can go to 2, and then we can say 1 and 2, and 3 would not be. Then we could say 4 and 6 and 8 and 10. Then we can go to 5, and of course we will have 1 and 5 and 10. Well, when we look at the numbers that's in common for all three, that number is 10. So in essence, 10 will be our common denominator. And we can take that 10, and this is where it's going to get a little bit confusing. we can take that 10 and multiply that 10 by each one of the rational numbers. And what that will do, it will eliminate the fraction. Okay? So let's take a look at the steps that the book tells us to do. First it says, well, determine the least common multiple of the denominators, and then we looked at 10, 5, and well, they said 10, 5, and 2, but of course we put the 2 over 1 as well, and we come up with 10. They show us here in the little box how they came up with it, and here we are here showing how we came up with it. You know, we pretty much getting the same thing. And the step 2 says, let's multiply both sides of the equation by the least common multiple or the least common denominator, which is 10. So if we multiply 10 times 7 divided by 10, we can simplify, as you see they're doing here, by simplifying the 10, and that's really 10 over 1. So they're simplifying the 10 and the 10, and we're getting 1, which is 1 times 7, and 1 times the actual 1, and you will get 7. Okay? So now we're taking a look at, well, what about the next one, the 3 halves? Well, again, you're going to multiply by 10, or we can say we're multiplying by 10 over 1, and we can simplify by dividing 2 into 2 one time and 2 into 10 5 times. It's going to give us a denominator of 1 on the bottom, and then of course 5 times 3 is just simply 15. Okay. Again, don't get paranoid with this. Just take it in stride. Practice, practice, practice. So let's go to the right side of the equal sign, and we see again we're multiplying by 10. We're taking every single term in this equation, and we're going to multiply that by the least common denominator or the least common multiple. So here we see 10 times 3/5, and again we can say that's 10 over 1. And 5 we can simplify by 5 divided into 5 one time, and into 10 2 times, giving us a denominator of 1. And then 2 times 3 is 6. Okay? Now, going on to the next one, and then this is simply something that you're familiar with. 10 times 2 will give us 20. So this very rough looking equation that we begin with is now simply 7n, and let's make sure that we, 7n plus 15 is equal to 6n minus 20. Okay, good stuff. Now all we need to do now is look at this equation and solve it the same way we've been solving the rest of the equation. So let's go ahead and see what step 3 is about. So step 3 says, let's use inverse operation to solve it. So here we want to get our constant terms together. Our constants are the 15. So in order to get those together, it says use the inverse operation. This is a plus 15. The inverse is minus 15, so we subtract 15 from both sides. There's our 0 pair. Bring down our 7n, and we're left with, on the left side, 7n. Equal sign comes down, is equal to 15 minus 20 will give us 5. So bring down your 6n and your 5. Okay, so now we have 7n is equal to 6n plus 5. Well, what we want to do now is look at our n's and see can we take them both to the same side. So 7n is the largest, is on the left. Let's bring 6n over on that side. So you see, since it is a positive, we subtract 6n from both sides. Okay, if that makes sense. We bring down our positive 5, and here gives us our 0 pair, and here on the left side, 7n minus 6n just give us 1n, and then here we have n is equal to 5. Okay? Good. Now, what I do have is I want you to take a look at this 1 and 2. Go ahead and pause it if you don't mind. Take a look at 1 and 2 and see what can you come up with in your own words about question 1 and 2 and how do they relate to the problem. So just go ahead and pause it and come back when you're ready. Okay, it asks us, what is the advantage of multiplying both sides of the equation by the least common multiple of the denominator in the first step? And then the second one says, what happens in the first step if you multiply both sides by a common multiple of the denominator that is not the least common multiple? Okay. Well, what's the advantage of multiplying both sides of the equation by the least common multiple of the denominators? It simplifies the calculation by eliminating all the fractions. It makes your calculation easier. That way you're not trying to remember, oh my God, what is what do that rule say? Do I add both denominators and numerator? What? Here you simply know that you turn these into integers, and it's simpler to add integers than it is rational numbers. Number 2, what happens in the first step if you multiply both sides by a common multiple of the denominator that is not the least common? Well, you would eliminate the fraction, but the results would not be, your equation. It says, but the results would fractions or not be an equation with greater integer coefficients. So in plain words, you may wind up still with fractions, or you may not get a greater integer coefficient. Okay, so you have to be careful and make sure that you are using the least common denominator or the least common multiple. Oh man, here's a good one. Let's take a look at these two problems. And here they're asking us to solve these two problems and use the process that we just did. So please go ahead and stop it. Take a look at this and work 3 and 4. Then come back. And when you come back, we'll work through it. Okay. Wow, this is a good one. So we see the first equation. It says 1/7 k minus 6 is equal to 3/7 k plus 4. It is not that difficult because we see we have denominators of 7, 1, 7, and 1. So our least common denominator is 7. So we're just going to simply multiply every single thing on both sides by 7. That's going to give me 7. Let's see, make sure. Draw. So that's going to give me 7 times 1/7k minus 7 times 6 is equal to 7 times 3/7k plus 7 times 4. 7 is being multiplied by everything. Well, here I can put this over 1, and as you can see, I can simplify. 7 and 7 will give us 1 and 1, so here 1 times 1 and 1. Excuse me. And then, of course, you have k that's left. So you could put the 1, or you can just put k. And minus, here we're looking at simply 7 times 6. That gives us 42 is equal to, and then we can do the same thing on this side. You don't really have to put the 1 on the bottom in the denominator if you choose not to. 7 divides into 7. That simplifies that to 1, and then 1 times 3 is 3, so that'll give us 3k. And here, put our plus sign, and of course 7 times 4 is 28. Well, looking at this, the 3 is larger, so let's subtract k from both sides. this is going to give me a 0 pair here, bring down my negative 42 is equal to 2k, that's 1 from 3, put that 1 there so you know, 1 from 3 will give us 2, and then bring down my 28. Now I want to subtract 28 from both sides, and when I do so, this is going to give me my 0 pair. It's going to cancel out. And over on this side, well, let's finish up with this side of the equal sign. I'll have 2k, and then here will give me a negative 70. This is 2 times k, so I want to divide by 2. And here I'm going to wind up with negative 35 is equal to k. Okay, so that's how you solve both 3 and 4. I solved 3 for you. Please do 4 on your own accords.